In this video, we are going to solve sparse number problem. A number is going to be a sparse number if it does not have two or more consecutive bits as set in its binary representation. According to the problem, in the input format, we are given that the first line of input contains an integer t which represents the number of test cases. The first line of each test case is number n. In the output, we should print 1 if the number is a sparse number. We should print 0 if the number is not sparse. In brief, if we find two adjacent ones in the binary representation of the number, we should print 0, else we will be printing 1. I have scanned the number of test cases. In order to iterate throughout the test cases, I have used a while loop. I have scanned the number n on which we should check whether it will be a sparse number or not. Our first task is to convert the given number into binary. In order to calculate the binary number of the given number, I am declaring an array of size 10. I am taking the size of an array as 10 because the maximum number of n is given as 1000. 1000 can be represented with 10 bits in binary. So I am considering 10 as the size of the array. I am using array in order to store all these remainders. So I am writing a for loop for calculating the reminders and storing them in the array. Here I have declared the variable len and I have initialized that to 0. With the help of len, I am going to find the length of the binary string. I am writing len ++. Each time I travel in the for loop, it will be incremented by 1. In order to store the remainder, I am modulo dividing n with 2. And since we are calculating the binary number, I am updating my n value to half of it. So now we have calculated the binary number for the given number. But in this array, the binary numbers are stored in the reverse order. Like, since we are counting from bottom to top, in that array also, they are stored in the reverse order. So we should travel in reverse order itself. So I am taking a for loop again for traveling in the reverse order. This for loop helps me to travel throughout the array A in the reverse order. Now our secondary task is to check whether we are having two adjacent ones or not. If we encounter two adjacent ones, we should print 0. In order to make the task easy, I am initializing a flag variable to 0. So I am having a condition statement that if a of I is equal to 1 and logical and a of I, that is 1, is equal to the previous index of it. Since we are moving backwards, we should consider the previous index. Then I am having flag as 1. I am breaking here. I am writing a break statement here. Why I am writing a break statement here is, if we encounter a pair of ones at least once, that is enough for us to decide that this is a non-sparse number. If the condition fails, then I am keeping the flag variable to 0 itself. So my task is half done. In the output, I should print 1 if it is a sparse integer. Since we have used the flags, I am using flags in conditional statements. If flag is 0, then I should print 1, which means that the given number is a sparse number. Else I am printing 0, which means that it is a non-sparse integer.